So today, we're going to talk about something that's quietly powering a lot of the tech you use every single day. You know, the streaming services you binge, the online stores you shop at. We're talking about microservices. It's an idea, an architectural style really, that has completely changed the game for companies like Netflix and Amazon. So let's dig in and see what this big idea is all about.
Have you ever had this happen? You're using an app, a tiny little update rolls out, and suddenly it breaks something that seems completely unrelated. It's frustrating, right? Well, it's not just you, and it's not just bad luck. A lot of the time, it's a symptom of a much deeper problem in how the software was built. And to really get why microservices are such a big deal, we first have to look at the old way of doing things. We need to talk about the monolith.
Okay, so this slide really lays it out. A monolith is basically one giant, single application. Imagine one big, complicated machine where every single part, the user login, the shopping cart, the product catalog, all of it is tightly connected. If you want to change one tiny gear, you risk messing up the entire machine. And here's the kicker. If just one part of that machine gets busy, you have to scale the whole thing, not just the one part that's doing all the work.
Yeah, and this analogy just nails it. Let's say it's Black Friday and your shopping cart service is getting slammed, but the part that handles user profiles is just sitting there. Well, too bad. With a monolith, you have to throw more resources at the entire application. It's super inefficient, it's expensive, and it's exactly why developers started looking for a better way. So if the monolith is the problem, what's the solution? Well, this brings us right to the heart of our topic today, microservices. Instead of building one giant application, the idea here is to break it down into a bunch of small, independent services. Each service is its own little self-contained unit. They talk to each other, sure, but they aren't all tangled together. Think of it less like one complex machine and more like a team of highly specialized experts. Each one knows their job, and they just collaborate to get the bigger goal accomplished. And the whole idea is that each service has one specific job. You might have a service just for authenticating users, another one just for searching products, a third one just for the shopping cart. And because they're loosely coupled, you can update or fix the shopping cart without ever touching the other two. You could even write each service in a completely different programming language if you wanted to. It's all about picking the right tool for the job. Now, as you can probably imagine, this approach has some massive advantages. And that's exactly why it's become the go-to for building modern, cloud-based applications. And the benefits are pretty huge. First, modularity. A new developer doesn't have to understand the entire system. They can just focus on one service. The scalability becomes surgical. You only add power to the services that actually need it. And for older companies, this is a lifesaver. You can modernize an old, clunky system one piece at a time, instead of attempting a scary, all-at-once rewrite.
You know, this quote really gets to the human side of it all. It's not just about the technology, it's about empowering teams. You have small, independent teams that own their services. They can innovate, they can deploy updates whenever they want, and that just makes the whole development process so much faster.
But, and there's always a but, right? There's no such thing as a free lunch in tech. Microservices solve a ton of problems, but they absolutely introduce a whole new set of complexities that can be, honestly, even harder to deal with. And here it is. This is the fundamental trade-off. All that complexity that used to be inside your single application, it hasn't vanished. You've just moved it. Now, instead of one big code base, you have dozens, maybe hundreds of little services that all have to talk to each other over a network. The complexity just shifted from the code itself to the operations of managing this distributed system. And the list of new challenges you have to solve is, well, it's not short. Every time one service calls another, you've got network latency. Testing becomes a nightmare trying to make sure all these moving parts work together. And simple things, like getting a report that needs data from 5 different services, that can suddenly become a massive project all on its own. So, given all those risks, how do you actually pull this off successfully? Well, the industry has learned a lot of lessons, many of them the hard way, and that's led to some clear best practices and, of course, common pitfalls to avoid. Okay, let's look at a classic problem. Service A needs some information from Service B, so it makes a request. The question is, how long should Service A wait for an answer before it just gives up? This is the timeout problem. And you're kind of stuck between a rock and a hard place. If you set the timeout too short, you might kill a request that was actually going to work, it just needed another second. That creates needless errors. But if you set it too long and one service is having a problem, everything that depends on it slows down to a crawl, and your users are just stuck watching a loading spinner.
It's a really tough balancing act.
So a really clever solution to this is called the circuit breaker pattern. It works just like the circuit breaker in your house. It watches the health of a service. If it sees that a service is failing over and over, it trips the breaker. It stops sending requests to the broken service for a little while. This prevents a system-wide slowdown and gives that failing service a chance to recover.
All right, here's another big headache, reporting. In a monolith, all your data is in one database, so running reports is pretty easy. But with microservices, your data is spread out everywhere. The big temptation is to create a reporting service that just reaches into all the other databases to grab what it needs. Don't do it. It totally breaks the rule that each service owns its data, and it just creates a fragile mess. A much better way is to have services push their data to a central place just for reporting.
So at the end of the day, it all boils down to this question. Microservices give you amazing flexibility, incredible scalability, and they empower your teams. But all that power comes at a cost, and that cost is a huge increase in operational complexity. They're not the right answer for every single project, so the real question you have to ask is this: is the flexibility you gain worth the price you'll have to pay in complexity?